Picture a warship cutting through violent ocean waves at night. The flight deck shakes beneath the storm, while two attack helicopters rise into the darkness, their rotors slicing through salty air. Minutes later, they are flying only meters above the sea, armed with rockets, missiles, and a cannon powerful enough to destroy armored vehicles in seconds. This is not ordinary helicopter warfare. This is shipborne combat, one of the harshest environments in military aviation. And for decades, one aircraft became the United States Marine Corps' primary airborne weapon in that unforgiving world. That aircraft was the Bell AH-1 SuperCobra. Unlike Army helicopters designed mainly for land warfare, the SuperCobra was built around a completely different mission. It had to launch from amphibious assault ships, survive corrosive sea conditions, operate far from air bases, and provide immediate fire support for Marines landing on hostile shores. The AH-1 SuperCobra was not simply an upgraded Cobra. It was a navalized gunship engineered specifically for expeditionary warfare. Its story is not just about speed or weapons. It is about creating a helicopter capable of surviving where the ocean itself becomes part of the battlefield. To understand the SuperCobra, we first need to understand the original AH-1 Cobra developed during the Vietnam War. Before the Cobra, armed helicopters were mostly modified transport aircraft carrying machine guns and rockets. They lacked the speed, protection, and agility needed for dedicated attack missions. Vietnam exposed these weaknesses quickly. Troop-carrying helicopters needed immediate close air support, but existing gunships were too slow and vulnerable under enemy fire. Bell Helicopter answered with a radical solution, a slim, fast attack helicopter built specifically for combat. The result was the AH-1 Cobra, the world's first purpose-built attack helicopter. Its narrow tandem cockpit reduced frontal profile, while short wings carried rockets and missiles without sacrificing speed. The Cobra proved devastating in Vietnam. But while the U.S. Army focused on land warfare, the Marine Corps saw another possibility. Marines needed a helicopter capable of operating from ships during amphibious assaults. That requirement would eventually evolve into the twin-engine AH-1 SuperCobra. Operating helicopters at sea creates challenges very different from land-based aviation. Saltwater constantly corrodes metal. Ship decks move with the ocean, weather changes rapidly, and maintenance opportunities are limited. The SuperCobra was designed specifically to survive these conditions. One of the biggest improvements was the transition from a single engine to a twin-engine design. Earlier Cobras relied on one engine, which created serious risks during overwater missions. A mechanical failure over land might allow an emergency landing. Over the ocean, it could mean losing both crew and aircraft. The SuperCobra solved this problem with two General Electric T700 turboshaft engines mounted above the fuselage. Even if one engine failed, the helicopter could continue flying. Engineers also redesigned major systems to resist corrosion. Components exposed to sea air received protective coatings, while electrical systems were sealed more carefully. Rotor assemblies and transmissions were strengthened for constant shipboard stress. These modifications transformed the Cobra from a battlefield helicopter into a true naval aviation platform. At first glance, the SuperCobra looks narrow and aggressive, almost like a flying missile with rotors attached. That design was intentional. Attack helicopters survive partly through maneuverability and partly by minimizing exposure to enemy fire. A smaller frontal profile makes the aircraft harder to hit during low-altitude attack runs. The tandem cockpit arrangement places the pilot in the rear seat and the gunner in front, dramatically narrowing the fuselage compared to side-by-side cockpit helicopters. This slim structure reduces drag and improves acceleration during combat maneuvers. Short stub wings mounted along the fuselage provide additional lift during forward flight. As speed increases, the wings carry part of the helicopter's weight, reducing strain on the rotor system and improving efficiency. Unlike transport helicopters built mainly for hovering, the SuperCobra behaves more like a high-speed attack platform designed for aggressive movement across the battlefield. The rotor system of the AH-1 SuperCobra was engineered for agility and reliability under extreme combat conditions. Helicopter rotors experience enormous stress during rapid maneuvers, dives, and weapons firing. For a shipborne attack helicopter, those stresses become even more severe because of unstable launch environments and strong sea winds. The SuperCobra used a two-bladed semi-rigid rotor system optimized for simplicity and quick maintenance. While more advanced rotor systems existed, Bell engineers prioritized reliability and compact shipboard storage. Simpler systems meant fewer maintenance challenges aboard amphibious assault ships where repair facilities were limited. The rotor blades could also fold, improving storage efficiency inside crowded ship hangars. In combat, the SuperCobra excelled at terrain masking, flying extremely low to avoid radar and visual detection. Pilots often maneuvered only meters above the ground or ocean surface, using speed and terrain as protection. This style of flight required precise control responsiveness. Even small instability at low altitude could become deadly. The SuperCobra's aerodynamic balance and responsive rotor system allowed pilots to perform rapid attack runs while remaining difficult targets. The AH-1 SuperCobra was designed around one core principle: overwhelming firepower delivered quickly and accurately in support of Marines on the ground. At the nose sat a 3-barrel 20mm M197 rotary cannon mounted in a flexible turret. Unlike fixed guns, the cannon could track targets independently of helicopter direction, allowing the gunner to engage threats while maneuvering. The weapon fired armor-piercing and high-explosive rounds at extremely high rates, making it effective against infantry, vehicles, and defensive positions. But the helicopter's true power came from its external weapon stations mounted beneath the stub wings. These hardpoints could carry Hydra 70 rocket pods, AGM-114 Hellfire anti-tank missiles, AIM-9 Sidewinder air-to-air missiles, additional gun pods. This modular setup allowed the SuperCobra to adapt to different missions. In one operation, it might focus on destroying armored vehicles with Hellfire missiles. In another, it could prioritize close air support using rockets and cannon fire. The inclusion of Sidewinder missiles was especially important. Most attack helicopters were designed only for ground combat. The SuperCobra, however, needed to survive in contested naval environments where enemy aircraft could pose direct threats. This gave the helicopter limited air-to-air capability, increasing survivability during amphibious operations. Modern attack helicopters are not just flying weapons. They are airborne sensor platforms capable of processing battlefield information rapidly. The SuperCobra integrated thermal imaging systems, laser rangefinders, targeting sensors, and night vision compatibility for operations in darkness and poor weather. Amphibious assaults often begin before sunrise or during low visibility conditions to reduce enemy detection. In those situations, avionics become just as important as weapons. Thermal imaging allowed crews to detect vehicles, personnel, and defensive positions even in complete darkness. Laser targeting systems guided precision missiles onto armored targets with remarkable accuracy. Communication systems also played a major role. The SuperCobra operated closely with Marine ground forces, naval units, and fixed-wing aircraft. This transformed the helicopter into more than a gunship. It became a networked battlefield asset capable of delivering firepower exactly where commanders needed it. By combining speed, maneuverability, naval adaptability, and concentrated firepower, the AH-1 SuperCobra became one of the most effective shipborne attack helicopters ever built. It was engineered not for traditional airbase warfare, but for expeditionary combat launched directly from the sea. Every element of the aircraft, from its engines to its weapon systems, reflected the harsh realities of amphibious warfare. And as future conflicts evolved, the SuperCobra would continue proving itself in some of the world's most dangerous combat zones. The true purpose of the AH-1 SuperCobra became clear during amphibious warfare. When Marines launch assaults from the sea, they face one of the most dangerous phases of combat. Troops moving from ships to land are highly vulnerable, while enemy forces often prepare defensive positions, overlooking beaches and landing zones. In those moments, immediate firepower becomes critical. Fixed-wing aircraft can deliver heavy strikes, but they often move too quickly to provide continuous close support. Attack helicopters solve this problem by remaining close to the battlefield and responding instantly to threats. The SuperCobra was engineered specifically for this role. Flying low above coastlines, the helicopter could destroy bunkers, armored vehicles, machine gun nests, and troop positions before Marines even reach shore. Its ability to hover, maneuver aggressively, and strike with precision made it ideal for supporting amphibious assaults. Unlike fast-moving jets, the SuperCobra operated within direct visual range of the battlefield. Pilots and gunners constantly coordinated with ground forces, adjusting attacks based on changing combat conditions. In close air support missions, that flexibility could determine whether an assault succeeded or failed. Operating an attack helicopter from a warship is far more difficult than operating from a normal airbase. At sea, flight decks constantly pitch and roll with ocean movement. Pilots must land on relatively small decks while dealing with darkness, turbulence, strong winds, and sea spray. The SuperCobra was designed to function in this environment. Its compact size allowed efficient storage aboard crowded amphibious assault ships, where hangar space was limited. Maintenance systems were also designed for quick servicing under operational pressure, enabling helicopters to return to combat rapidly during sustained operations. Marine expeditionary forces depended heavily on this fast operational tempo. During amphibious assaults, helicopters could launch repeatedly within short periods, refueling and rearming between missions, while ships remained near hostile coastlines. This demanded exceptional reliability. Mechanical failures that might be manageable at large air bases became unacceptable at sea. The SuperCobra systems were therefore optimized for maintainability as much as combat effectiveness. The aircraft also integrated closely with naval command systems. Pilots received targeting updates and threat information directly from fleet assets, allowing helicopters to function as extensions of naval power rather than isolated aircraft. Over decades of service, the AH-1 SuperCobra participated in numerous military operations that tested both its engineering and combat doctrine. During Operation Desert Storm in 1991, Marine SuperCobras carried out attack missions against Iraqi armored formations and defensive positions. The open desert environment exposed helicopters to radar-guided anti-aircraft weapons and mobile missile systems, forcing crews to rely heavily on low-altitude flight and terrain masking. The helicopter's speed and firepower proved highly effective. Hellfire missiles allowed precision attacks against tanks at long range, while rockets and cannon fire suppressed enemy infantry positions. Later wars in Iraq and Afghanistan introduced different challenges. Urban combat environments created constant threats from hidden rocket-propelled grenades and portable anti-aircraft missiles. In these conflicts, survivability depended not only on armor and weapons, but also on pilot skill and battlefield awareness. SuperCobra crews adapted continuously, using unpredictable flight paths, rapid attack runs, and coordination with ground forces to reduce vulnerability. The helicopter's flexibility became one of its greatest strengths. Unlike aircraft designed for only one role, the SuperCobra could quickly switch between reconnaissance support, escort missions, anti-armor strikes, and urban close air support. Attack helicopters operate dangerously close to enemy forces. Unlike high-altitude aircraft, they cannot rely entirely on speed or distance for protection. Survivability must be engineered directly into the aircraft itself. The AH-1 SuperCobra incorporated armored protection around critical cockpit areas, shielding pilots and gunners from small arms fire and shrapnel. Transparent armored glass protected the cockpit while maintaining visibility during combat maneuvers. Critical hydraulic and flight control systems were built with redundancy. If one system was damaged, backups allowed the helicopter to remain controllable long enough to escape hostile areas. Fuel systems were designed to reduce fire risk after crashes, while engine placement minimized the chance that a single hit could disable both power plants simultaneously. Infrared suppressors reduced the helicopter's heat signature, making it harder for heat-seeking missiles to track. Electronic countermeasure systems further improved protection by detecting radar threats and deploying defensive flares or chaff when necessary. But perhaps the most important survival factor was tactical doctrine itself. The SuperCobra survived not by absorbing punishment like a tank, but by combining speed, low-altitude maneuvering, terrain masking, and rapid attacks to avoid becoming an easy target. As warfare evolved, so did the demands placed on marine attack helicopters. Modern battlefields introduced advanced air defenses, digital warfare systems, and increasingly networked combat environments. To remain effective, the SuperCobra platform required modernization. This led to the development of the AH-1Z Viper, an advanced evolution of the SuperCobra family featuring upgraded avionics, improved targeting systems, enhanced survivability, and a 4-blade composite rotor system. The new rotor dramatically improved lift, maneuverability, and vibration reduction. Advanced sensors increased night fighting capability and target acquisition range, while new mission computers improved integration with modern battlefield networks. Despite these upgrades, the AH-1Z retained the core philosophy established by the SuperCobra, a fast, compact, shipborne attack helicopter designed specifically for marine expeditionary warfare. The transition demonstrated the strength of the original design. The SuperCobra platform proved adaptable enough to evolve across decades without abandoning its core mission. The AH-1 SuperCobra represented something larger than a single helicopter program. It reflected the strategic philosophy of the United States Marine Corps itself. Marines are built for rapid deployment, expeditionary warfare, and amphibious assault. Their aircraft must therefore operate independently, often from ships far from established infrastructure. This requirement shaped every aspect of marine aviation. Aircraft needed to be compact, reliable, versatile, and capable of operating under harsh logistical conditions. The SuperCobra embodied those principles perfectly. It combined mobility, firepower, and maritime adaptability into a platform capable of supporting Marines wherever they deployed. From deserts to coastal assault zones, the helicopter served as both shield and sword for expeditionary forces operating in hostile territory. The Bell AH-1 SuperCobra was far more than an attack helicopter. It was a machine engineered specifically for the brutal realities of shipborne warfare. Its twin-engine design, narrow airframe, advanced weapon systems, and maritime adaptations transformed the original Cobra concept into one of the most effective naval gunships ever built. For decades, it provided the Marine Corps with rapid response firepower capable of launching directly from amphibious assault ships into some of the world's most dangerous combat zones. Where conventional attack helicopters focused mainly on land warfare, the SuperCobra mastered a far harsher environment shaped by saltwater corrosion, unstable flight decks, and limited maintenance resources. Its success came not from one revolutionary technology, but from the integration of aerodynamics, naval engineering, weapon systems, survivability design, and combat doctrine into a single platform. The SuperCobra proved an important lesson about military engineering. The most effective States Marine Corps, that mission was clear. Project firepower from the sea and support Marines wherever they fight. In that mission, the AH-1 SuperCobra became more than a helicopter. It became the flying gunship of amphibious warfare itself.